Patty from Thronatisca. Today we're going to talk about something light. It's all around you, except when it isn't it's dark. But we take it for granted and we really don't understand a lot about it. But it's a pretty complex phenomenon. The light that you see, just the normal light that comes from the sun, or the normal light that's coming from the lights right here, is called white light. And the interesting thing is light is called different words. We could call light simply light, or what scientists call light, they call it the electromagnetic spectrum. So they can say the EMS and sound really important. Now, light is something that is called radiation. So it sounds scary because we think radiation, oh no, I'm going to grow a tail and horns. No. It's really not scary. It's all around us, and it's part of everything that we do. The cell phone that you use, the words that we hear that are coming from the radio, all of that is coming from the electromagnetic radiation, or otherwise known as the electromagnetic spectrum. A lot of big words. You might also hear the word photon thrown around in there a time or two. So there's lots of different things that all mean basically something that we've known all of our life, light. Now, light, we only see this very, very small part of the electromagnetic spectrum, and that's called the visible light. Our eyes are trained and have receptors to pick up this part of the electromagnetic spectrum, and it is called the visible spectrum. Now, other species, like bees that fly around, they see a part that is over here. So their vision is a little bit different than ours. And that's why plants have the colors that they do, because they can give off a type of light that we can't see, which is ultraviolet light. So they see something a little bit different, something with a little bit more energy to it. Now, light is categorized. We got to categorize everything, because teachers wouldn't have anything to do if we didn't break it down, study it, and put it into categories. I'd be without a job. So it's categorized by two characteristics, which really breaks down to one characteristic. But it's the wavelength, and that's how long it is from either the crest of the wave or the trough of the wave. Now, when something has a long wavelength, it travels pretty slowly. And when something has a very short wavelength, it travels very quickly. So just like a turtle that travels very slowly, it doesn't have a whole lot of energy. So this kind of waves, these are radio waves. This is how you can listen to your radio. Something that has a whole lot of energy, this is like X-rays or radiation that comes from something breaking down. This can be very damaging because there's lots of energy. But today, we're going to focus on this small part right here, the visible spectrum, or that little visible portion of the spectrum. So if we break white light down, white light, represented by my white pipe cleaner, can be broken down into red, orange, yellow, green, blue, indigo, which I really don't have, and violet lights. And so I can model the differences in wavelength and energy with these different colors. So if you look at a rainbow, funny thing about a rainbow, you check this out, make sure I'm not lying to you. The rainbow goes in this order. We call it Roy G. Biv. Okay, red, orange, yellow, that's your Roy, G for the green, and the B for blue, and then I for indigo, which is kind of between blue and purple, and then V for violet, okay? If you look at your rainbow, it's going to break down the colors of the light into those colors, Roy, G, Biv. And you're going to notice that the red is always going to be in a certain position. I'm not going to tell you because you've got to find that out. Now, whether it's a rainbow that is made by the rain, and what's happening is the rain droplets are a little prism and they're breaking the light apart, or whether it's a rainbow that is made by you using a water hose and spraying water, and then you look at it from an angle. Either way, you can make a rainbow. What's happening is the water are like little lenses, and the droplets are breaking the light apart. And I'm not going to tell you which way it goes. You are going to figure that out on your own. But the red is always going to be either on top or on the bottom, and then vice versa, the violet is either going to be on top or the bottom. But I'm going to let you figure that out. I'm not going to tell you. You can try it different ways. You can look at rainbows today, tomorrow, or 10 years from now. And it's always going to have the same order, Roy, G, Biv, but you can check, and it's always going to be the same. It doesn't matter whether you're using your sprinkler, a hose, or the rain. It doesn't matter if it's now or 10 or 20 years from now. It's always going to be in a certain order, and the red is either always going to be on the top or the bottom, but I'm going to leave you to find that out. So if you'll notice, the red has a long wavelength and does not have a lot of energy. So whenever you go into a place that is a restaurant where they have to keep pizzas warm or something like that, they might use a red light. Now, the great thing about this, there are lots of super applications. Just like we can break light apart, you can also put it back together. Now, this is cool. I have what's called little filters here, okay? Different colored filters. And we're going to talk about how NASA can use different colored filters to see different things from different solar systems. But let's first of all do a little activity where we can break our light apart and then put it back together. And we just need 3 filters. So you're sitting at home and you're going, okay, well, I don't have those fancy little filter paddles. But guess what? All you need, like I got this from the Dollar Tree, some kind of plastic that is red, green, and blue. That's all you need. You may even be able to get some plastic cups that are old, that are see-through at home, and break them apart. Don't tell your mom and dad, or maybe you might want to get their permission. But all you need is clear see-through plastic. You need the 3 colors, the red, the blue, and the green. Now, I need a flashlight, and when I turn my flashlight on, you can see that you've got red light coming out of it, and you would like to have a black or a white background for this. I've got blue light coming out of it. I take my green. I've got green light coming out of it. But when I put all 3 of them together, you've just got plain white light coming out of it. Now, it doesn't look like there's anything coming out of it because what's coming out of it is just your plain old white light. It looks just like the light that's around you. So the great thing about light is it can be taken apart and it can be put together. NASA uses this feature to study different objects. Lenses can have filters applied to them. So we would call these colored filters. And when you look at a picture, you can put the different color filters over it, and you can see different things. So I urge you, when you go home, or maybe you're already at home, to get some different colors. You need these 3 see-through colors. Get some pictures and see, how does it look? Does it look different to you when you apply color filters? Can you get a flashlight? Take your light apart, run that water hose, and see that rainbow. Tell me, is the red going to be on the top and the violet on the bottom? Or is it going to be the other way, with the violet on the top and the red on the bottom? Use some color filters. Take your light and put it back together so that you make white light. And you can also make any shade in between. So if you take the red and the yellow together, I know, you're going to get orange. But what can you do when you put different layers of colors on your light at home?